Hello guys, we want to deal with binomial expansion today, and we'll be using this topic. We are going to be majoring on how to expand a an expression that is raised to power number. For example, let's say we have a plus b. Let's say a plus b all raised by n, for instance. Now, or let me even take it to the power of 1, yes, which means it's same as 1, 1, and the coefficient of what? Of x, a and b is 1, 1. If I say a plus b all square, it means we want to have it as 1, 2, 1. Then the coefficient of that will be what? 1, 2, 1. What about if we have a plus b all raised by 3? What about 1, 3, 1 plus 2 is 3, 2 plus 1 is 3, then 1. And so forth. And we have a plus 4 or a plus b all raised by 4. Then we can have it as what? 1 plus 3, drop this one, 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4, and here is 1. This is what we call the Pascal triangle. You continue like that, so that if you want to expand, for example, let's say a plus b all raised by 4, for instance, it's just for you to see 1, 4, 6, 4, 1, for instance. And in that case, you now decrease one by what? You start from 4, a raised by 4, a raised by 3, a raised by 2, then a raised by 1, then a raised by 0. Then you go with the other one. This one start the other coefficient of factor will become what? B raised by 0, b raised by 1, b raised by 2, and b raised by 3. Let's see. Okay, I did not start from here. This one is b raised by 0. Sorry, is b raised by 1, b raised by 2, b raised by 3, and b raised by 4. It must end with 4, factor of power of 4. So you can now what? Place an addition in between. You are simply what? Expand this one through the meaning of what? Through Pascal. So we call Pascal triangle. We can start even with 1. So we call it Pascal triangle. But there are other methods that we can use to expand better than this one. So we try to see how far we can use our other method. For instance, if I give you a plus b all raised by 4, we can use what? Combination method to expand. You can say any combination of 4 combinations 0, then a raised by 4, b raised by 0, plus 4 combination 1, a raised by 3, b raised by what? 1. That means this one is decreasing by 1. The a is decreasing by 1, while the b is start from 0 and keep increasing by 1. Then we are going to have 4 combination what? 2. Then a raised by what? 2, b raised by 2, plus what? 4 combination 3, a raised by 3, b raised by 1. Then lastly, we have 4 combination 4, a raised by what? This is 1, b raised by 3, then 4 combination 4, a raised by 0, then b raised by 4. Because this is combination method, which some people will take as for 4 factorial, but 4 minus 0 factorial, 4 factorial, the 0 factorial, a raised by 4, b raised by 0, plus what? 4 factorial over 4 minus 1 factorial, 1 factorial, then a 3, b raised by 1, plus 4 factorial over 4 minus 2 factorial, then 2 factorial, a square, b square, plus, you go to this place, we are here now, 4 factorial over 4 minus 3 factorial, 3 factorial, plus what? What? Sorry, a1, a raised by 1, b raised by 3, plus 4 factorial, 4 minus 4, 4 factorial, then 4 factorial, then a raised by 0, b raised by 4. Do not forget, this is what we call using what? Combination method. You understand? This method is what we call combination method. Although what you can learn from here is that this is first term, C1. This second term, T2. This third term. This is fourth term. And this is fifth term. Now, if you check very well, if you check clearly, rather, you will discover that when it was first term, here the R was 0. That means first term, R was 0. Second term, R was what? 1. Second term, R was 1. Check. What's the R here? 1. Third term, R was what? 2. Fourth term, R was 3. And the fifth term, R was what? 4. Therefore, we can now conclude the statement on that n term is equals to, can be gotten by R plus 1 term. The statement of this formula first, the first formula. So that means if I give you the sixth term, the sixth term it actually means R equals to what? 5. If I give you seventh term means R equals to what? 6. If I give you the 10th term, it means R equals to 9. You should be able to familiar. If I even give you what the third, okay, let me give you the 11th term, then R equals to 10. So if you check now, there is a difference of 1 between what? R and n term. So please take note of that. In case you have solved your R to be 20, you should then know if my R is 20, for instance, class, what will be my n term? My n term should be what? The 21st term. So that is how that one works. Now, I will give you number 2 equation, but I will have to clean this one first. There's something I want to give you in case we now have a power that is not fraction, what do you call it? That is not a whole number. A number that is not natural number. If n, for example, you are giving what? A plus B plus B all is power half. It becomes difficult because half combination what? 0 will be giving you error because your n should be what? If I give you something like this, A plus B all is power what? N. Your n should be greater than or equal to R. It cannot be less than. So in that case, that brings me to the version of the formula I want to give you that we will apply in the next class. This class is just an introduction class that we want to apply in our next class. So take note, what I only show you here is just binomial expansion and using combination method to expand. But we are going to have a limitation. If I give you something like this, you can quickly do it, no problem about it. This one is just what? Very straightforward. Use power of 3. If it's going to power of 5, you can go further to say 1, 5, 10, 10, 5, 1, and so forth and so on. But if I give you power of 3, for instance, you just write 1, 3, 3, 1. Then decrease the first factor by what? By 1, 2, that means 1, 0. Then the second term, we increase it by what? From 0 to 1 to 2, then to 3. So you now add root plus at the middle. You have actually what? Expanded. That was what we did in this first video. But in our second video will be more direct, and I will be showing you a formula that can solve. Because if I give you something like this now, there will be a limitation to this question. If I give you something like this, or even make it minus, to use binomial expansion will be very, very difficult, thereby taking us to the next level of the video. Ensure you stay tuned and watch very well the next video. Study the next video so that you can appreciate this one, because sometimes the next video will make it better. This particular one we want to go to now, how to expand this one cannot do this. By Pascal triangle cannot do this. Rather combination method cannot do this. But we are going to give you a simple method that will make it easy. Thank you. God bless you.